In this lesson, we are working on the application of our radical functions with the graphs. So we're using these three questions as a kind of review and making sure we're good to go with our graphs here. So go ahead and pause the video, and here for each of these three questions, we're identifying which of the two phrases in each of the questions is the true statement. So just go ahead and pause the video, and you can underline, circle, whatever you choose to identify the true statement. And here we go. So in number one, here, as my x's and my p of x. So as my x's are increasing, so this is a way of actually asking for the end behavior. So as x's are increasing, what's happening to our f of x, or to our graph? It's going down, it's decreasing. So that's why it was the second piece here. So then in number two, as x approaches infinity, what is our end approaching? Negative infinity. So that's again all the same, just words and symbol. Now here it's a little different because as x approaches 3, because we're stopping now here at 3. So as x approaches 3, what is our end approaching? 6. So that's why here it was the second piece, because the graph is not going on and on and on to infinity. So now again, looking at this application. So like here, for example, we're given this graph that models days before the phone release. So again, days before, right? So that's why here we're going to be in the negative, because it's all about before the release date, because then the positive would be after the release date. Then the number of pre-orders in the millions. So our Y is going to represent the number of pre-orders of the phone. Then the X is going to be represented by the days before the phone release. So here, we're again going back to using our function. This is the graph here. Notice how we're starting, right, at 0, 20. So this is the start of our graph. So basically, actually, we'll get to that pretty soon here. But just again, making sure we're good to go with the transformations of our function. So notice here, and we could see this visually. Like, for example, our negative here. Well, we actually have two negative values. So it's not only a reflection over the x here, so we have a reflection over the x-axis, we also have the negative inside. So we have the reflection over the y-axis as well. So we have a double reflection. Then also notice we have this value here too on the outside. So this represents our vertical stretch by a factor of 2. Then last here, notice how we have the plus 20. Well, notice, did we start at 0, 0? No. What happened? We moved up 20. We moved up 20 units. So now that's the transformations. Now, what is the y-intercept, and what does that mean in terms of this scenario? So same as before, like with our quadratics. What is the y-intercept? 0, 20. And then what does it mean in terms of this situation? Well, 0 is our x, 20 is our y, right? So here at the start, how many number of pre-orders were there? 20 million. So at the start, there were 20 million pre-orders of the phone. So again, it's still going to represent that start. Or in this case, we could say leading up to the sales, the end, right? But technically, that's where it's going to start. What is the domain of this function, and what does it mean? So here we go. So the domain, our domain is all of our x values, right? Starting at 0. So our x values starting at 0, and here, because remember, right, we're talking about days before, less than or equal to. So here, what does the domain represent in context of the situation? Now, again, we could have our, What does it mean in context of our situation? Well, again, what do the X values represent? The days before the phone release. So the days before the release. So then what is the range of this function, right? And what does it mean? So again, the ranges are Y values, starting here at 20, and again, going down, less than or equal to. And then what is the range in context of this situation? The number of pre-orders. So again, that is our Y values here. So now we're going to actually take a look at and interpreting our graph. So like, for example, how many days before the phone release will the company get 10 million pre-orders? So 10 million, remember 10 million is our Y, and how many days before? So here's our 10 million. So we got to go over to the graph to see about how many days before. So here we're at about halfway through -20 and -30. So about 25 days, 25 days before the phone release. Because again, remember, right, the negative represents the before leading up to the sales. So 25 days before, they would have already reached 10 million pre-orders. So then how many pre-orders is the company predicting to have 30 days before? So again, now we're looking at 30 days before the release. So 30 days before, here is the number. So we are just below that 10 million. So we could say like maybe like 9.5 million, right? So just before. So this is just an approximation. So then looking 20 days before. So here's 20 days before here. Now notice we're just above. So we could say maybe 10 or 11 million pre-orders. So same thing here, we're looking at our next graph. So what is the X? Our X is the depth of water. And what is our Y? Our Y is the speed of the water drainage. Now notice, we are not necessarily starting at 0, 0, so keep that in mind. So this is where the transformations come in. So there are two transformations. So go ahead and pause the video and go ahead and identify the two transformations here. And here we go. So notice how everything was inside, right? Our two transformations, our two values that represent our function. So this is not a horizontal stretch, but a horizontal shrink. Because what is the factor? Because it's not 64, right? We're shrinking by 1/64. Then here, x minus 2. Well, that's not 2 to the left. If you notice, right, we move from 0, 0, just a little smidge to the right. So this is 2 right. So that's not at 0, 0. This is technically at 2, 0, because we moved 2 to the right. So now again, go ahead and pause the video and identify what is the domain of this function, and go ahead and identify what is the end behavior. So here we're talking about as x approaches infinity, and as x approaches, maybe not necessarily, and we'll continue not with negative infinity, but as x approaches our x value of 2. So go ahead and pause the video now and do these two questions on your own. And here we go. So the domain is your x values starting at the value of 2. And we're going greater than or equal to 2. And what is our domain in the context? The depth of water in the tank. So now the end behavior, as x's are approaching infinity, what is our end approaching? Infinity as well. Now, as we're approaching though 2, what is our end approaching? 0. So as we're approaching, as the depth of water is approaching 2, the speed of the water is approaching 0, because that is our y. And then here, number 4. So go ahead and pause the video and try to identify and answer question number 4 now on your own. And here we go. So now here, the 70 feet per second represent the speed. We want to know what is the depth. So we need to find 70 feet per second, which is the speed, which represents the y. So here we're going to look for 70, which is halfway here. So then what is right here? So what is the depth of the water? 80 feet. Now, question number 5 is calculating the average rate of change. Now, if we don't recall, average rate of change is just another way of asking for the slope, but we're going to take the average, all right? So like here, for example, we are talking about the average rate of change from 2 to 20. So this is our x values again, our interval. So interval is x's. So from 2 to 20. So we are looking at this portion of our graph, and we're going to estimate. So we need the rise and we need the run. So remember, slope is rise over run. And again, this is just estimating. So here, I'll move it over here. So for our 2 to 20, our rise is, well, we're going from 0 to just above 30, right? Notice how this is 30 here, but we went just above it. So we could say like 35. We went from 0 to 35, so that's 35. Then we went from 2, remember, right? Not 0, 2 to 20, so that is 18. So the average rate of change here, right, is our rise over our run. So here, what is the rise? 35. And what is the run? 18. So now here, what is 35 over 18? Approximately 1.9. Now keep in mind, this is not just 35, right? This is 35 for our speed. So feet per second. So that's our speed. Then the 18 represents the feet. So here, that 1.9 represents our average rate of change, which is showing how much time it takes here. So now let's take a look at our 140 to 160. So 140 to 160 now. So here we're going to identify from We're going to identify from 140, which is here, to 160, which is here. So now notice, is it as steep as before? No. So we're going to deal with a much shorter rise and run. Now notice here, this is just about 5, right? We went from about like 95 to 100. So this is only 5. And our run here, so 5 over, we went from 140 to 160. So this is 20. So 5 to 20. So really, this is just approximately 0.25. So notice the difference in the average rate of change, right? The steepness. So here, our first section had the greatest rate of change. And notice too, the steepness of the graph, how it's much steeper in the beginning, and then it starts flattening out here in the end. So here that means our speed is greater with our feet and with the time, and then start slowing down. Go on and pause the video now, and you're going to do the you try here with this graph on your own. So notice now, and this one's nice, we are starting at 0, 0, because notice with our transformations, there is no up and down or left and right. So we are starting here at 0, 0. And here we go. So if it takes 4 seconds, how long is the pendulum? So 4 seconds, well, you have to identify where is our time. That's our y here. So looking at 4 seconds, how long is the pendulum? So here at 4, about right here, halfway between 12 and 14, which is 13. So 13 here, so 13L or 13 feet. So that is how long the pendulum is. So then for the next one, if the pendulum has a length of 2 feet. So now this represents your X. How many seconds will it take? So now you have to look at X, the 2 here, which is right here. So just below 2, but in between 1 and 2, so about 1.5 seconds. Now, what is the average rate of change from 8 to 10? So now remember 8 to 10, that is your X here, that's your interval. So from 8, which is here, so we could say that it's just above 3, so we can still say that that's 3. So from 3, and then so 10 is here, so that's just about 3.5. So we're going from 3 to 3.5, which is just 0.5. Then our run is, well, 8 to 10, which is 2. So our rise is 0.5. Our run was 2. Remember, right? Because average rate of change slope is rise over run. When you divide, you get an average rate of change of 0.25 seconds for each foot. And what is the domain and range of the situation? So the domain is your X values are greater than or equal to 0. And what is the situation? This is your length in feet. That is your domain. So then the range is your Y values, again, starting at 0 and going up, up, up. So greater than or equal to 0. And in terms of the situation, this is our time in seconds. Then number 5. As X values, or the length of the pendulum, right, as they approach infinity, as they are increasing, what is our time approaching? So as we're increasing, what's happening to our time? It is also increasing to infinity.